So let's do this question. It is a sliding window problem, obviously, because we are given a fixed window size and we want to know the first negative integer in the window. Yeah, it says that find the first negative integer for each and every window contiguous sub array. Yeah. See, how to identify it is a sliding window problem is that it would have this subarray, contiguous subarray, yeah, and the fixed size k, and you want to know about something given, and you want to. I have made an answer vector, and I'm going to return that vector, yeah. So first of all, let's see here. Yeah. See here -1 obviously, here also -1 because it is at the first, sorry, 3 on a, okay, -1, -1, -7, yeah, -15, then -15, then 0, I think, yeah. That's how you do this. Here 0 and here also 0. Okay, got it. So what can I do is that I'm thinking of is that first of all we make a ij here, yeah, while j less than this -10 because it's a fixed size, yeah. So j less than size, yeah. And what we're gonna do is that we're gonna um we're gonna j plus plus up to the this, and we're gonna see whether it is negative or not. If it is negative, we're gonna put it in our answer, yeah. Size is okay, then the first one would be our the answer, and the next one I think don't wanna take. If one time we have taken, we don't wanna take the another one. Got it. Okay, let's, so what can I do is that int I equals 0, j equal I equal j equals 0, while j less than r dot size, um if j less than k, j plus plus, if it is k, then um we're gonna search for int k go, not k, p equal I to less than um equal to j, if j plus minus I plus 1, j minus I plus 1, um p plus plus if r p less than 0, answer dot push back um r of p. Yeah, and just break. We have got the answer thing, and we're gonna I plus plus and j plus plus. We're gonna move on. Mm, hmm. What? Wow. Wait, let me check. In the brute force we can do like we can make a bool function. Um Bool found true, not false. It's found. Let's call it true. If not found, then ans dot push back 0. Yeah, it is told that if it is not found, then push 0. Okay, okay. Um, what is the error that I'm not getting? So the answer would be like this is the error that is making like this, comma this. Can't make like bro the syntax error, bro. Even now that makes me bad. This thing, this is the brute force, yeah. We can do better approach than this also. So TLE, time limit exceeded. Yeah, term limit is exceeded. 6. Big of n square or something. Big of this is big of n. This is big of n plus something. Yeah. We can solve this, optimize it. Let's see how. So now let us optimize this solution. Um, let's do it. First of all, what you're gonna do is that um, we're gonna use a tick tq. Yeah, um okay, we need answer. We need I 0 J0, also a vector of int answer. We gonna, sorry, return that answer. Nice. um let's code it. While um j less than array dot size, if j minus I plus 1 is less than k j plus plus, before that if array of j less than 0, if it is less than 0, then we want to put it in our key deck d dot push array of j. um Else if it hit the uh if it hit the like the equals k, then uh first of all we need to calculate and get the answer. So the obviously first edge case is that if deck is empty, 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 if it is empty, yeah, then we need to just ans dot push back our if it is empty, then d dot front, no, sorry, 0, firstly it is not empty, then we have to just ans dot push back that d dot front, yeah, yeah, then what we can do is that we have to also like slide increase the sliding window. So when I plus plus and j plus plus is the thing to slide the window, but before see j plus plus we do, then again it will put the element if it is negative, yeah, into the deck, and sorry, no deck, q, let's see, we are using q, yeah, sorry, yeah, then if but for I plus plus there will be something, yeah, we have to check if our R of j is less than 0, then we have to just pop, obviously popping from the front, pushing from the end, yeah, let's check some more optimal optimized solution. Mm, what? Your output minus. Oh, um, sorry. Here will be I. Uh, okay. Now, what is the error? Minus it. 0, 0, 6, 6, 6, 1, 6. What? Minus it is good. C2 minus 0. Hmm. Should be minus 6, obviously. Uh, what is there? Let me. Yeah, very basic errors. If this is not true, then also it is working. So we don't want it now. If it works, then it should work. See here in this, yeah. So the time complexity difference is obviously there. Yeah, we are just moving in big of n here, but there big of n plus k. So that's the difference. And in the problem, time constant is like mm, to 10 to power 6, so which is a rough about big of n. You can do like big of n, but it cannot exceed that. That's why we have used big of n, and we used lots of if and else codes. Yeah, what we have done is that, for example, take a example to dry run. Yeah, so we are like we are taking this example. Yeah, first of all we are using a deck, oh sorry, q. Yeah, we are using ij0 and vector answer, yeah, where the answer would be returned. Yeah, so while j is less than, obviously it should not exceed the n value. Yeah, it should be n minus 1 obviously. And if array is, see, first of all we are gonna push the negative elements, yeah, up to the like the up to the size of the window. Yeah, and obviously the element which is pushed from the in the queue, first last in first out, so the last element would be in the front, and we're gonna get it from the front. If you wanna pop it, front element will be popped. Yeah, so there is a good thing about this is that uh, when it is negative, we're gonna pop the only the element which has came the first last in first out. Now first in first out. Yeah, FIFO, first in first out. So that's why we are using q. Yeah, so first of all, if r of j is less than 0, if it is less than 0, we're gonna push it. If it is not, we're gonna increase the j. J is here, first of all, j, then here you push minus 1, then push minus 7. Yeah, it is done. Then we have to just if it is q is empty, then we push answer and 0, else we have to push the front element. Yeah, then it is done. Now we are going to move the sliding window, array of I. If it is negative, we're gonna pop the d, that is q. Yeah, and increase I plus plus and j plus. Obviously, j would be if it is negative element. Yeah, if it is negative element, it will gonna be pushed or popped. If it gonna negative, it gonna pushed. Otherwise, nothing will happen. J plus plus of obviously j plus plus means yeah, because it is here shows. Obviously, it is not less than. Obviously, it will be j equals to k. See, when we are why we are using this type of uh thing, how it is optimized more, yeah, than the previous code, because when we are coding in the previous, first of all we are doing like this window, yeah, we then again loop is there for, then again -1 is came, yeah, we just pushed it and just break, and then we have uh, and we have just like we repeatedly do this now, repeatedly we are doing this, that we are just um, moving to the element and we are finding negative element, first negative element from um like we are traversing this twice. If it is here, it will be twice traversing, which is not good optimization. Here what you're doing, you just move, you just push it, but the space complexity obviously big of n because of q, it is increased, yeah. In that case, the there is a something better in space complexity in that code, yeah. So here you will be moving here, yeah, it will be -1, then again here all be -1, then push, if it is negative, see, if it is negative, where if it is negative, I'm gonna pop it and I plus plus and j plus plus, yeah. So front element obviously have that element. If it is here in this, there is empty, so it gonna push 0. That's how it is easy. And obviously the time complexity big of n and space complexity obviously big of n. Thanks. Like, share, subscribe, and comment and share. And the much you share, the much I will be delivering quality contents. Thanks.